Uh, so, this already I have done. And advantage, disadvantage, what are the components of an art dams? So generally it has eight components and advantage, disadvantages. What are the advantages? The design procedure are easy, local natural materials are used. And what may be the disadvantage? An ardent embankment. What, what happen in an ardent embankment? It may easily break, isn't it? It may easily destroy due to water. And if the soil is not properly compacted, the dam may break. The hardened dams may break. Okay. So generally, this type of dam is not used in hydraulic power plant. Only concrete and gravity dam is used for hydraulic power plants. Okay. Again, classification. Based on the materials, arts materials, it is classified as homogeneous zone hardened dams and diaphragm hardened dams. Design criteria. So these are the design criteria of hardened dams. Next, we are going to discuss about diversion headwork. Okay. Structural failures. What may be the structural failures in an hardened dams? Failures of RNM due to earthquake, failures due to foundation slide, failure of RNM due to slow protection, failure due to damage caused by borrowing. There is a problem related to design of hardened dams. The problem we are not discussed here. We are not going to discuss the problem. You will get in design structure subject, RCC design structure. Design of arc dam. So what is arc dam? Uh, Dam barrage weir structure is a natural or man-made obstruction or barrier built across a river in between the two ends of the river to raise the water, called head of the structure. A barrage is built to divert this river water into the nearby link canals. A dam is built to utilize the head of power generation and for storage. And dam are classified in different types. Arc dam is one of the type of dam. As the name implies, it is a curved obstruction from the upstream side. Let me show you. So, arc dam, arc dam is an arc-like dam. Okay, the upper portion is curved. That's why it is called arc dam. Is a curved obstruction from the upstream side, singly span that mainly carries the load of the impounded water through arc action as well as cantilever action. Arc dams do arc action transfer portion of the load of the water horizontally. Okay, let me show the figure. Okay, this portion is location of an arc dam, advantages, disadvantages. These things are important. Yes, in this figure, these are the components of an arc dam, which is very, very important. Okay. So in an arc dam, it has arc-like structure. This is the base width. This is the arc width. This is, and there is one radius. So there is a central angle. And this is the downstream phase. This is the upstream phase. Okay. If you cross section this portion, then it will show this is the base width. This is the upstream phase, height, axis, base, toe, downstream phase, and upper portion is crest. Okay. The above is a typical plan and cross section of an arc dam showing typical components part of an arc dam. So let's see what are the advantages, disadvantages of arc dam. The major advantage. Okay, let me discuss about the situations where arc dam is used. Okay, generally arc dam is not commonly used. Okay, so arc dam is proved most economical and efficient when the width of the canyon or valley to be spanned on the river is least. So if there is a canyon and if the width of the canyon is small, then we can use arc dam. As a major share of the impounding water thrust is backed by abutment walls resting on the sides of the canyon, thus this must be stable, strong and firm. Arc dam can be used most economically on a terrain where width of the valley is less than 6 times the height of the at a height, or in other words b by h ratio is less than 6. What is b? Width, h is the height. If b by h ratio is less than 6, then we use arctan. If the area is remote such that the naturally available material are not enough to provide sufficient supply of concrete or earth fill, arc dam should be used as it needs minimum amount of construction concrete. The slope of the adjoining hills for the abutment should be steep, more than 45 degrees. During the design of the arc dam, it is considered that the stresses generated are up to the allowable stresses of the concrete. And advantages, the major advantage derived from arc dam is minimal amount of concrete filling. That means we required we required less amount of concrete while designing an arc dam. Okay, that is one important advantage of arc dam. The major advantage derived from arc dam is minimal amount of concrete or filling material is required. These dams are best suited for a narrow canyon, passes, and can store water as well as generate electricity. Arc dams are particularly adapted to the remember arc dams are not ardent dams, okay? Arc dams are concrete dams. Arc dams are particularly adapted to the gorges where the length is small in proportion to the height. For a given height, the section of the arc dam is much less than the corresponding gravity dam. Hence, an arc dam requires less material, is therefore cheaper. Because of massless base weight, the problem uplift pressure are minor. Since only a small part of the water load is transferred, the foundation can be constructed in modern foundation where gravity dam requires sound rock. Okay, so gravity dam construction it requires sound rock, but we can construct arc dam in a moderate type of soil. Next disadvantage, these are particularly adapted to for a given height a section. So generally, we arc dams are not preferred for a bigger valley. Okay, and types of arc dam: shell arc dam, a famous aesthetical marvel; constant ready arc dam, best suited for U-shaped valley; variable radii arc dam, best suited for V-shaped valley; constant angle arc dam, design of arc dam. A complex hectic. Okay, design of arc dam. The loads which are considered in designing an arc dam are water pressure, earthquake pressure, wave pressure, ice pressure, temperature pressure, and silt load. Okay. Arc dams are designed and engineered by three famous methods: thin cylinder theory, theory of elastic arcs, and the trial load methods. Next, so the design of arc dam, only you remember the methods. Detailing we are not discussed here. So next chapter we have one very important chapter is your diversion headwork. Okay. So any hydraulic structure which supplies water to the off-taking canal is called a headwork. So, what is a headwork? Headwork, any hydraulic structure which supplies water is called a headwork. A diversion headwork serves to divert the required supply to the canal from the river. So, diversion headworks is a channel. So, these are the channels generally supply water and carry water from the structure to the river. Okay. The purpose of diversion headwork. It raises the water level in the river so that the commanded area can be increased. It regulates the intake of water to the canal. It controls the silt entry to the canal. It reduces fluctuations in the level of supply in the river. It stores water for tiding over a small period of short supplies. Location. Location of a diversion headwork. So, in what situation we require diversion headworks? The diversion headworks are generally located in the boulder stage or trough stage of the river at a site which is close to the commanded area of off-taking canals. Okay, boulder stage. Boulder stage means in river there are different stages. Okay, one is rocky stage, another is trough stage, and next is boulder stage. In boulder stage, In boulder stress, what is happen? The bed is made up of a mix of sand, gravel, boulders. As the bed material is very pervious, river in stays have straighter course. Okay, so in boulder stays, the river has straight. The river is straight, not in zigzag, not in a curve motion. Okay, so the straight stage of the river is known as boulder stage. And this is the first point of location of diversion headworks. Next, if there are a number of sites which are suitable, the final selection is done on the basis of cost. Next, the site which gives the most economical arrangement for the diversion headworks and a diversion works canal is usually selected. The river section at the site should be narrow and well defined. The river should be have high, well defined, erodible, and non submersible banks so that the cost of the river training works is minimum. So we have to construct a diversion headworks in those stages where the river is inerodible, non-submersible banks. Okay. Next, the canals taking off from the diversion headwork should be quite economical and it should have a large command area. There should be a suitable arrangement for the diversion of river at the time of construction. The site should be such that the V or barriers can be aligned to right angles. There should be suitable locations for under sluices, head regulator, and under another components of a diversion headworks. There should be suitable locations for under sluices, head regulator, and other component of the diversion headworks. And diversion headworks should not be submerged. Costly land and property on the upstream. Good foundation should be available at the site. The required material of construction should be available near the site. The site should be easily accessible by road or rail. The overall cost of the project should be minimal. Next, another important point of a diversion headworks is component parts of a diversion headwork. So, what are the component parts? It has a weir or barrage, under sluices, divide wall, fish ladder, canal head regulator, pocket or approach canal, silt excluder, or silt prevention devices, river training walk. That means marginal banjan guide Mary. What is river training? Suppose this is the river. Due to the heavy flow, due to the heavy current of water, the banks gets eroded, isn't it? So, to protect the bank from erosion, we have to use some structures here so that the flow of water can be diverted. Okay, that is your river training works. So, in this figure, uh, let me remove the. Okay, so in this figure, these are the marginal banks. This is the river. Okay. Here, these are the silt excluder, head regulator, canal. This is the canal. This is the under sluice. This is weir or barrage. This is fish ladder. This is the divide wall. And these are the marginal band. Okay. So under sluices. What is an under sluice? Already you know what is weir or barrage. In fourth sem, you have already have one. You have already that means got to know about weir and barrage. Okay. So what is under sluices? Under sluices sections are provided adjacent to the canal head regulators. Here, to the canal head regulator under sluices are constructed. The under sluices should be able to pass fair weather flow for which the crest shutters on the weir proper need to be dropped. The crest level of the under sluices is generally kept at the average bed level of the river. Next is divide wall. A divide wall is a wall constructed parallel to the direction of flow of river to separate the weir section and the under sluices section to avoid cross water flow. Okay. So a divide wall is a wall constructed parallel. Okay. Constructed parallel to the direction of flow of river to separate the weir section and the under sluices section to avoid cross flows. If there are under sluices at both the sides, there are two divide walls. So this is a cross section of a diversion walk fish ladder. So what is a fish ladder? A fish ladder is a passage provided adjacent to the divide wall on the weir side for the fish to travel from the upstream to the downstream. So fish ladder generally is a passage to flow passage provided for the flow of fish. Fish migrate upstream or downstream of the river in search of food or to reach their sprawling places. In a fish ladder, the head is gradually dissipated so as to provide smooth flow at sufficient low velocity. Suitable baffles are provided in the fish passes to reduce the flow velocity. So inside the fish ladder, baffle walls are provided. Okay, so that the fish can reduce its flow. So these are the fish ladder. In the figure, you can see in this figure, these are the fish ladders. Okay. Canal head regulator. Canal head regulator is provided at the head of the canal of taking from the diversion headworks. It regulates the what is the uses of canal head regulator? It regulates the supply of water into the canal, controls the entry of silts to the canal, and prevents the entry of river floods into the canal. Next is your silt excluder. A silt excluder is a structure in the undersluices pocket to pass the laden water to the downstream so that they can clear so that only clear water enters into the canal through the head regulator. The bottom layer of the water, which is highly charged with silt, pass down the silt excluder to escape through the under sluices. Okay. Next is guide band. Guide band and marginal bank. Guide banks are provided on either side of the diversion headworks for a smooth approach and to be prevent the river from outflanking. Marginal bands are provided on either side of the river upstream of diversion headwork to protect the land and property which is likely to be submerged during ponding of water in floods. Weir or barrage. A diversion headwork is a structure constructed across the river for the purpose of raising water level in the river so that it can be diverted to the obstructing canals. So advantage and disadvantage of weight and barriers. These things you study yourself. Types of weeds, vertical drop rock fill and concrete. Next we have, yes, we have canal irrigation. Okay. In the next class we have this. We will continue in the next class. Okay. So 29 students. Let me mm, attendance. Today is 19. Okay. So Tejuvino Crow, are you present?
Yes, ma'am.
Crow. Okay.
Yes,
Next,
ma'am.
K Honu Chotu,
Present, ma'am.
Memisan Debarma,
Present,
Marilyn
ma'am.
Debarma, Onyam, Nivea,
Present, ma'am.
Senjam,
Present, ma'am.
Larry, Yang Bam Jeshila,
Present, ma'am.
Kevejito Keho, Wilson,
Yes,
Kichu.
ma'am.
Wilson present?
Yes, ma'am.
Wilson, okay. Next, Kichu absent, I think. Zoda SM,
Yes, ma'am.
Zoda SM present. Benishan,
Yes, ma'am.
Thrice, Toksham,
Yes, ma'am. Yes, ma'am.
Deepak,
Yes, ma'am.
Gyani Zamatia, absent, I think. Jashan, Kasi, Lachung, Pranay Chakraborty. I think this student left. Bengia Kha, Bengia Kha,
Present, ma'am. Yes, ma'am.
huh? Okay.
Present, ma'am.
Rupasri, Rupasri, Modusmita Haloy,
Yes, ma'am.
Imliangar Jamir, Pokoto,
Present.
Imliangar, absent. Okay, Kishan, he went for vaccination. Walishan Jamir,
Ma'am, Kilitoli
uh,
present.
Khilitoli present. Okay, Pokoto, absent. Khilitoli present. And
Yes, ma'am.
Nakshimongla,
Present, ma'am.
Noksimongla,
Present, ma'am.
okay. Margas Mayak, Mirging Partik, Omit, Fiba, Rahun, Taba,
Present, ma'am.
Raju,
Present,
Lanu,
ma'am.
Lanu Temjeng,
Pres-
present.
Present, ma'am.
Fika Chohe, Fika Chohe, absent. Likha, Likha Tagu, Sevitonenu. Present. Seyevitu. Absent. Nanupadum. Present. Christina
Present, ma'am.
Nopi. Christina. Christina Nopi present. Febina. Christina Nopi
Yes, ma'am.
absent. Febina present. Josnaline Tipi.
Yes,
Present.
ma'am.
Margarite. Margarite. Absent. Puritemic.
Present, ma'am.
Okay. Okay, thank you. Thank you. You can leave. Notes I will share today.